Okay, so for this quick video, we want to find the derivatives of these three different functions using the power rule. And it's always a really good practice to express each of the functions using exponents. So let's first start off with f of x. F of x we see up here is 5 divided by x cubed, which is the same thing as 5 times x to the negative 3 power. So in finding the derivative using the power rule, our 5 will be multiplied, our negative 3 will come down out front, and then our power is going to drop by 1 in our exponent. That's going to make negative 15 divided by x to the 4th power. We now move on to g of x. G of x is initially written as the cube root of x. Well, we know that's the same thing as x to the 1/3 power. So for its derivative, we're going to have our 1/3 come down out front as a multiplied coefficient, and then subtract 1 from the x. And this turns into 1/3 times x to the negative 2/3 power. Writing this back as a radical again, we have 1/3 and then 1 over the cube root of x squared, or just 1 over 3 times the cube root of x squared. For our last derivative, for h, we have our original h of x is equal to 1 over the square root of x. Using the rules of exponents, this is x to the negative 1/2 power. So when you use the power rule for this derivative, we're going to have our negative 1/2 come down out front. The power is going to drop by 1. So that's going to be negative 1/2 times x to the negative 3/2 power, which is going to be negative 1 over 2 times the square root of x cubed, which does simplify down to negative 1 over 2 times x times the square root of x. And now if we look back at the original notation for all of these problems here, we'll notice that the original problem, f of x, have rational notation. We have our answer in that form. For g, we start off with a cube root, and our final answer is also a cube root. And then finally for h, it was 1 over the square root, and you'll notice that we have a 1 over square root as well. So once again, be very important to make sure that you are consistent with your notation, so that if a problem is posed to you as a radical, you give it back as a radical. If it's rational, you give it back that way, and so on. Consistency is very important here.